These are our notes for section 2.7b for college algebra. We've started talking about inverse functions in the first part of our notes, and we just reviewed how we find that we switch our x and y's, then we solve for our new y, and then we check to see if that inverse is a function. And if it is, we use that inverse notation. Okay, so starting today, it says find the inverse and then prove algebraically that they're inverses. What was the method we had to show that the two functions were inverses? Look back in your notes. We did some compositions. When we did the original function with the inverse, and when we did the inverse function with the original, what were we supposed to get? What? X, yes. All right, both of them should give us just a plain x, because inverse functions undo each other, right? The inverse of adding 5 would be subtracting 5, okay? So when we compose two inverses, they should cancel all those operations out. So first of all, f of x is our y, so we're going to switch x and y. And then we have to solve for y. So what would we do first? Okay, let's multiply our 4 over. And then, okay. And what shape is this? Yeah, right, y equals mx plus b, it's just a line. So would it pass the vertical line test? Yeah, so this is a function. So we could say 4x minus 3 is the inverse of our original function. Okay, so we've done the first step. We've found the inverse. Now they want us to prove algebraically that we got the right thing. Okay, so we're going to do two compositions. We're going to do the function with the inverse. Okay, so our original function was, sorry, we didn't switch it yet. Our original function was x plus 3 divided by 4, right? And now instead of that x, we want to dump in our new inverse function, right? So we're going to take this expression and dump it in there, okay? So we've got 4x minus 3 plus the 3 divided by 4. And remember on Friday we talked about the order that things drop out in being really important. So what would the first thing cancel out? All right, so subtracting 3, adding 3 is going to drop out. So we end up with 4x divided by 4, and then we can cancel the 4's, all right? And we just get our x, okay? I'm going to pause the video. I want you to do the other composition, okay? So you're going to do f inverse of the original. So you're going to start with the inverse function and dump the original one in, okay? Go ahead and try that. All right, looking at our composition here, we've dumped our original function, x plus 3 divided by 4, into our new inverse function, which was 4x minus 3. What's the first thing that cancels out? This time the 4's cancel out first. All right, so we have x plus 3 minus 3, and then our 3's would drop out. So things cancel in the opposite order. And remember, for your test, you have to state this. You have to tell me which composition you're doing, and you have to show me each step that leads to that final x. Okay? All right, our second one. If this is y, we're going to switch x and y. Our next step would be to bring that 1 to the other side by subtracting it. And then how do we undo a cube? We cube root it, yes. So do we need the plus and minus in front of a cube root? No, we just need that when it's an even root. Okay, so we've got our inverse. Do you remember the shape of a cube root graph? That was one of our main functions that we looked at the beginning of this unit. It kind of is a sideways twist type thing. So would that be a function? Yes. So we can write the inverse of our original is the cube root of x minus 1. Okay? Again, we're going to do our two compositions. So let's take the original with its inverse. Our original function was x cubed plus 1, so something cubed plus 1, and we are going to dump our inverse function in there. Okay, what cancels first? What do you think? The cube and the cube root? Okay, so we have x minus 1 plus 1, and then our 1's would cancel out. Okay, then we're going to do the other composition. So starting with the inverse function and dump in the original. So our inverse was the cube root of something minus 1. And what we are dumping into it was our original function, x cubed plus 1. So this time, instead of the cubes dropping out first, our 1's drop out, and we have the cube root of x cubed, and then the cube and cube root cancel each other. Okay? Questions about that whole process? Can we find the inverse function? And then can algebraically prove that they are inverses? Okay. We looked a little bit at parabolas in the first part of this section. I want you to talk at your tables. If we were to graph y equals x squared plus 1, what is its shape and what kind of transformation have we done to it? All right, so we talked about this being a parabola that has been shifted up 1. So do you know your basic parabola points? Okay, we normally have a vertex at 0, 0, go through the point 1, 1, and negative 1, 1, 2, 4, and negative 2, 4, right? But now we're going to shift everything up 1. So we have this picture. Okay. Is that a function, what we just drew? Yes, passes the vertical line test. It's a function. Will its inverse be a function? How do we know? Okay, and your reasoning, you can say fails horizontal line test, HLT. But now the question is, what if we restricted the domain? In my original, I was using everything for x, right? It's just a basic parabola. But what if I restrict it to just being 0 or higher? Okay, now I'm saying I just want this half of it. Okay, would that half pass a horizontal line test? Okay, could I have used the other half? All right, so either way I can restrict the domain to create something that would have an inverse that's a function. Okay, so sometimes you'll encounter a formula, but then they're going to have a domain restriction. They're going to say, we're just going to look at this part of it, find the inverse of that. Okay, so let's say our x value is greater than or equal to 0, or in our interval notation. If we restrict the domain just to that, then it would be a function. All right, so we're going to look at two different options. We're going to look at if we restrict the domain to be 0 to infinity, and if we restrict the domain to be our left side from negative infinity up to 0, but not past it. Okay? Going back to our picture, what would the range be if I just look at this green half? What would you say your range is? 1 to infinity? Okay, is that the same for the other half? If I just look at the red half. Still going 1 to infinity? Okay, so we're going to list that the range is from 1 to infinity for both of these. And the reason we do that is when we find the inverse function, remember we switched our x and y's? So now my range becomes my domain, and my domain becomes my range. So if we identify them right away at the beginning, all we have to do is flip them around for our answer. Okay. All right, so we had the function y equals x squared plus 1. Our parabola shifted up 1. What would we do to find the inverse of that? Okay. I'm then going to move my 1 over. And how do we undo a square? We square root. And normally, with just a basic parabola, when we square root that to find its inverse, we would put the plus and minus in front, right? But because we restricted the domain, we are just looking at the positive root for this one, okay? Our x's were from 0 to infinity. We just are looking at the positive part of that. Over here, we started out with y equals x squared plus 1. We do our inverse, so we switch them. We subtract our 1, just like we did on the other side, and then we square root. But now I want the negative version of it, okay? So instead of having a plus and minus, I've split it into two separate things. So for this one, my domain is what I used to have for a range, okay? So 1 to infinity. And my range is what I used to have as my domain, 0 to infinity. Okay? Same thing on here. I'm just going to flip them. So my domain is what I had for range, and my range is what I had for domain. Okay? So looking at our graph, if we just take the green part, okay? That was the first one we did, just the positive from 0 to infinity for x. When I do the inverse of that, instead of having the point 0, 1, it's now the point 1, 0. Okay? Instead of having the point 1, 2, it becomes 2, 1. Instead of having the point 2, 5 up here, it becomes 5, 2. So we get that square root picture, but we're just looking at the top part of it. Okay? And then if I did the red part, like we did on the second one, it would just be the bottom half of that. Does that make sense? Okay, so this red piece has this as its inverse. Does that make sense? And we've kept them as functions, all right, by restricting that. All right. This one says, find the inverse of f of x equals the square root of x plus 2. Then identify the domain and range of the original and the inverse. So I'm going to pause the video for a minute. I want you to talk about what's its general shape and what's its domain and range to start with. Okay, so in walking around at the tables, I heard you say it's a square root graph, right? We've talked about that. General square root graph looks like that. Okay, which way did it move? Move left to. So now my picture looks like this. Yes? So what is the domain of this one? Okay. And the range? I'm starting at 0 and going up. Okay. So let's find our inverse function. We had y equals the square root of x plus 2. We're going to switch our x and y's. How do we undo a square root? We do have to square both sides. So we're going to square this, we're going to square this. It'll cancel my root on the right-hand side, and I just get y plus 2. On the left, I end up with an x squared. Okay. Then I subtract my 2 over. Oops. What shape is that? It looks to be a parabola, right, that's been moved down 2. However, we did not start with a whole sideways parabola, right? We just started with the top curve. So when we look at this inverse function, we have to think about switching our x and y, our domain and range, okay? The domain for this has to be what the range of the other one was, which was from 0 to infinity. And the range has to be what the domain had been, which was -2 to infinity. Okay, so I'm just flip-flopping those, which means when I look at my graph, instead of the whole parabola, all right, that was shifted down to, instead of the whole thing, I only have which side? If my domain has to be from 0 to infinity, I only have that part of it. Okay, this would not be part of my answer. So if your original function has a restricted domain, you have to keep in mind what that's going to do to your inverse function. It's going to restrict it as well. Okay? Questions on that? All right. So for day 2, you are going to do 39 to 45 odd, 59, 61, 69, and then you're going to skip to page 326 and do 85 to 96.